Alright, now let's take a look at some of the problems that we've got in our class that we're sitting here doing. So we'll set that aside and get us out a brand new sheet of paper. And the problems we're working are going to be very similar to what you just saw. Let's take a look at our very first example here. So, vectors and their properties. A car travels 20 kilometers due north, 35 kilometers in direction 60 degrees west of north. Find the magnitude and direction. So this magnitude means it wants us to find the R value. The resultant direction is saying it wants us to find the theta in the problem. So we've got two vectors in this question. So I'm going to start out right here. So we'll start out our problem with a set of crosshairs, as I usually call it, set of axes. It says to begin with, a car travels 20 kilometers due north. So this car starts out by traveling 20 kilometers due north. Now, once it gets to this point, alright, I'm just not happy with this picture. So you know what I'm going to do? Scratching that. I can definitely draw better than that. So let's see what we can't do here. Take number 2 on that. So let's get this a little bigger, nice set of crosshairs here. So it says that this car starts out by traveling 20 kilometers due north. So we start out 20 kilometers due north. And then it says the car then travels 35 kilometers, 60 degrees west of north. Now it's trying to be a little different here. It's being sneaky. It says that it now travels 35 kilometers at an angle of 60 degrees west of north. So west of north is in this quadrant up here. So let's see what we can't do. 60 degrees west of north. So 35 kilometers. So there's 35. An angle of 60 degrees west of a north line. Now I'm going to do something to make this problem just a little bit easier. I'm going to take my angle to be 30 degrees north of west. So 60 degrees west of north is the same as 30 degrees north of west. The reason why I'm going to take this angle off of the x-axis, it's just going to make it a little bit easier later on to work the problem, because now if we take all our angles off x, our x's are always cosines and our y's are always sines. Alright, so now let's do a sum of the x and the sum of the y based on this picture. I'm going to try and work it over here. So, sum of the x's would be equal to, well, the first vector has no x component, so that makes it kind of easy. So we'll go straight to the second vector. It has an x component, but it's a negative x component. So we're going to write negative, in this case, 35 cosine of 30. And at this point we're actually done with our x's and can put equals. We'll do a sum of the y's next. This one has a positive 20 y vector or component, so we're going to write plus 20. This vector also has a positive y component. Its y value is also directed up. So we're going to write plus 35 sine 30, which that kind of makes the math easy, plus 35 sine 30 equals. Let's grab a calculator and punch these numbers in. Of course, cosine of 30 is 0.866. So we'll go 35, negative 35 cosine 30 is negative 30.3 for an x. So negative 30.3 for an x value. So the next is positive 20 plus 35 sine 30 gives us a 37.5 y value. Now let's use that information to come back and do one brand new crosshair. And so now let's figure this out. So we've got a negative 30.3x component. That tells me to come over negative 30.3x, so 30.3 west, and a positive 37.5 y component. Positive 37.5. And what I'm looking for in this problem now is this. I'm looking for this resultant. I'm looking for this angle. The resultant would be 30.3 square plus 37.5 square. So 30.3 square plus 37.5 square. Let's take a square root of that answer. So we've got an R value of 48.2. And this was all in kilometers, so 48.2 kilometers. And let's see if we can find this theta. Theta would be equal to tan negative 1 of the opposite being 37.5, over the adjacent being 30.3. And let's see what we get for this. Shift tangent, 37.5 divided by 30.3. It's like we got 51.1 degrees. Let's write this in a full notation here. And let's write this out as your final answer is 48.2 kilometers at an angle of 51.1 degrees north of a west line. So there's our final solution to the first example. Alright, let's move on. Let's do the next example. Looks like Superman. That would probably be a rip-off, so I'm sure the problem's using some kind of just plain superhero.